Good afternoon, fellow Patreons. This is the progress I've made so far on my second do-it-yourself VEX Electric Car. This is the one that uses two Razor 24-volt scooter motors that are run at 12 volts for safety at half speed. You can see here that I upgraded the original VEX Legacy microcontroller to a newer VEX Cortex microcontroller, and I've installed it, and I've installed the battery, which is a 12-volt SLA battery. Theoretically, you can use two 12-volt SLA batteries in parallel so that the car will run even twice as long at 12 volts. The blue battery connected to the VEX Cortex can theoretically be a 9.4 volt battery also. The one that VEX sells for their usually used for the old remote controllers, the RC ones, and that'll work also. And in fact, I've been able to even run it at 12 volts. So it's a very good, has a wide input range up to about 12 volts to power the VEX Cortex. Right now I'm powering it separately just in case there's any short circuits, but operationally I could run it off the 12 volt battery also. Here you see the two rectangular HB25 motor controllers. They're from Parallax. Parallax now sells a newer version, the HB50, which can handle, I think, two motors per controller and can handle higher currents and maybe even voltages. But these are the older models, the HP25s. Here you see there's a relay with all these wires connected to it, which switches the 12 volt power supply using a push button power switch, a heavy duty push button power switch. You can also use a toggle switch, but this push button switch is going to be mounted on the top, easy to access in case there's any emergencies. Sometimes they sell the industrial mushroom ones. They have like a big red button. Those are very useful for this application. I just don't happen to have one right now. This is a close-up of the power switch connected to the 12 volt power supply and also to the relay. The relay switches not only the 12 volts, but it also can switch the 5 volts required for lighting and things like that. I provide you all the schematics that I used to do all the wiring for the 12 volt power supply and also the VEX Cortex connections to all the motors and sensors, including the bumper switches and all the lighting, including the LED signals, turn signals, and brake signals. This is the VEX game controller that I'm going to be using to start unit testing the motors and the sensors, including all the bumper switches, and also to test the lighting, including the signals and turn signals and brake lights. Okay, here you can see the top of the game controller has two joysticks and 8 push buttons. The two joysticks I'm going to use to start testing the two motors, and you'll be able to see the wheels turn when I turn it on and push the motors either forwards or backwards. I mean the top joysticks forwards or backwards to make the car go forwards or backwards. It uses tank steering, so in order to turn I have to push one joystick up and the other one down to make it turn left or right, whichever direction they're programmed in. Here you can see the wheel which is connected to the scooter motor via a chain. This is a standard 1/4 inch chain, and there's a large sprocket on the wheels. These wheels I bought surplus on eBay. They're from they might be from motor scooters or from electric chairs, but they're surplus, and usually you can find them on eBay or maybe even Amazon. You can also use the the wheels from an old broken Razor electric bike, which has a similar sprocket and chain drive system. This is the other side of the electric car, showing the left wheel, and this is the right wheel with the chain drive. You can see I have both wheels with the chain drive attached to the 24-volt motor scooter, Razor motor scooter motor, blocked up so that the wheels are not touching the ground. This is a safety measure that's very important to carry out during the software unit tests and software integration and tests, and even the calibration and alignment tests that you'll need to be able to do later. You can see the front wheels of the electric car. They are basically just freewheeling caster wheels. They can be found such as in carriages at supermarkets, but you can buy them at the hardware stores such as Lowe's or Home Depot, or any of your local hardware stores should have them. And they basically just turn around freely, and they're needed because this electric car is steered using tank steering instead of a Ackerman with a steering wheel, rack and pinion with a steering wheel, which a real car would use. Of course, if you have a toy Ackerman steering rig, you could always use that for your steering and then hook up a steering wheel to it. Here you see the two front bumper switches. If any object or person touches them, it'll immediately stop the vehicle, the electric car. And there are two of these in the back too. They are made from standard VEX bumper switches with some of their their spacers, aluminum spacers, that stick out about 2 inches. This is so that it gets a chance to contact the object and stop the car. Here you see the back of the electric car. The two wheels are mounted on an axle, a 1/4 inch steel axle, and they're mounted on ball bearings, so that the wheels normally are freewheeling, but using the chain and sprocket drives, it drives the wheels directly and just uses the axle for support during the motion. This is a close-up of the two bumper switches on the back. Again, these use about 2-inch spacers, aluminum spacers. That's what they're mounted on. Each one of us mounted on, and the wires go through the piece of metal to the VEX Cortex using some long extension wires that I made using wire wrap wire. Okay, here you can see the wires leading into the VEX Cortex. Most of the sensor wires I used wire wrap to go long distances, longer than, let's say, 5 or 6 inches, which are the normal cable lengths that come with the VEX Cortex sensors and motors. For the motors, I used wire wrap to go into the HB25 controllers and then tied them into the VEX Cortex using pin headers, wire wrap pin headers that you can buy on DigiKey or other places, Jamaico, SparkFun, or even Adafruit online. For the most part, I wire wrapped all the wires and used solder as little as possible. You can solder them if you want, but I like wire wrapping because it's pretty rugged, and then I can make it permanent, or at least for semi-permanent, using liquid tape, the black liquid tape that you can buy at electrical stores or hardware stores.